Hi, Geometry Advanced students. This lesson is a midterm review for your first midterm part. This is part 1. It's going to cover chapters 1 to 14 and some logic. So let's get started. First, just a little bit of a warm-up. Questioning is which two planes intersect in line AB. Just a note for this problem right here. There are so many different answers. Just going over a couple of the problems, let's say if I'm trying to intersect in this line right here, I could have this plane here and the one behind it, and that would intersect right there. I could have this top plane again right here, and if you can see this, it would be this one that kind of slides down to the front sort of at an angle, okay? So that also would intersect in AB. Another option might be something like this, where we could have two planes, like the one in the back, like ABF, and then ADB, something like that. Those would also be planes that intersect in line AB. Just remember, planes do not have edges. They don't have sides. Planes they extend without end forever. So if one of your questions may be ever to ask you if, how many edges does a plane have? You would say none. It's a trick question because planes don't have edges, okay? Which angles are vertical angles? So angles are vertical angles if they are across from each other like this, like angle 1 is congruent to angle 4. Those are called vertical angles, so that would just be A. Two angles these also are vertical here, but they don't have any numbers on them, etc. If angle 1 is 50 degrees, so there's angle 1, and that's 50 degrees. What's the measure of angle 2? Well, if this is a line like that, 50 and this angle from here to here, that adds up to be 180. You would just say 180 minus 50 degrees, and that'd be 130 degrees. So that's right there. Another option for this is to possibly say, oh, there's a vertical angle, 50, 50, and then I could have said this plus this adds up to be 180. Either one, same answer. Which angles form a linear pair? Now remember, a linear pair is basically two angles that share the same side like that, but also add up to be 180 degrees. So 5 and 6 are a linear pair, and so are 3 and 2. But there's no 3 and 2 on here, so that's out. So we would just say angles 5 and 6. For this problem right here, it says fill in the reason that justifies each step. So we are given that QS, this whole length right here, is 42 degrees. And so, if this whole length is 42 degrees, QS is 42, and we know that X is 13, so that's X right here, or we're trying to prove that X is equal to 13. So we're going to go through the steps. So what we have is we are given that QS is 42. So if QS is 42, that's given. I'm just going to write that in there, given, okay? Then what it says is QR, this segment here, plus RS right here is equal to QS, the whole thing. What we're doing is we're adding segments, so that's the segment addition postulate, segment addition postulate. Then what we did was we replaced QR, see here's QR, with X plus 3. We replaced RS, which is 2X, with that, and that's just substitution. Property of equality. Then it looks like we just simplified these. We combined like terms. We had 2x here plus 1x is 3x plus 3. So that's just simplifying. They're calling it combining like terms. So that could be right here. This next step, we're subtracting 3 from both sides. So we have 3x equals 39. So that's a subtraction. Subtraction, property of equality. And then it looks like we're dividing by 3 on both sides. So that's going to be x equals 13. So that's the division, property of equality. So the next question says, which pair of angles must be congruent? Supplementary angles can be congruent only if they form perpendicular, they're right angles here. So that's not always true. Complementary angles can only be congruent if they're 45, 45, but vertical angles are always congruent. Adjacent angles, again, are only congruent if they, form right angles, and also, actually, you could have adjacent angles look like that as well. So they're not always congruent. The other ones are sometimes congruent, but not always. This problem right here says which two segments are congruent. Segment AB has a length of 3. HJ is 1, 2, 3, has a length of 4. CD has a length of 5. DE has a length of 3. We don't know what that length is, but we do know that's 2 and that's 2. So if you remember Pythagorean theorem, a squared plus b squared equals c squared, this actually is just going to be 2 root 2. Which is not congruent to anything else. So I'm looking at AB and DE because those two segments are congruent. So that would be my first choice right there. The next problem says solve for y. So we are looking for y. We know that these two angles here and here are congruent. And so what you're going to do, because they are vertical angles, so solving for y, we're going to set these both equal to each other because they are vertical angles. So we're going to say 3y plus 20 is equal to 5y minus 16. I'm going to subtract 3y, I get 2y. I'm going to add 16, I get 36. So I get y is equal to 18. So for this problem, I get B. Just a note that on the test, I'm probably going to ask you to plug that in and to find the actual angles. So you would say either 5 times 18 minus 16, or you'd say 3 times 18 plus 20. So either one, doesn't matter because they're vertical angles. You're going to get the same angle measurement for both angles. The next question says, which counterexample shows that the following conjecture is false? Everyone at a high school is a student. So these are all students except for Mrs. Lawrence, who's not a student. The next question says, what is the converse? Now remember, the converse, the way these go is this. If P happens, then Q happens. That's your conditional. If you flip them like this, then you have if Q happens, then P happens. That's your converse, okay? The inverse does this. If P doesn't happen, then Q doesn't happen. And then the contrapositive is if P doesn't happen, Q doesn't happen, and it's the converse of that. So if I just want the converse, basically my conditional that says if P happens, then Q happens, the converse will be if Q happens, then P will happen. So that's what I'm looking for. So this says if you play the tuba, then you play an instrument. So then you want to hear, you're looking for if you play an instrument, then you play the tuba, which is going to be my C. The next question says, use the conditional, two angles are congruent if the two angles are vertical angles. Your hypothesis, that's what happens after the if. So that would be two angles are vertical angles. The conclusion would be then the two angles are congruent. But you don't use the word then, you don't use the word if, those are out. So don't use then, don't use if. The converse is going to flip them backwards. So that's going to say if two angles are vertical angles, then the two angles are congruent. The inverse is the not. And so that's going to be if two angles are not congruent, then the two angles are not vertical angles. And lastly, or almost last, if two angles are not vertical angles, then the two angles are not congruent. And then the biconditional is two angles are congruent if and only if the two angles are congruent angles. Just a note, if and only if is always going to, for the biconditional, is going to happen in the middle of the sentence. Additionally, there's no if and then in the front of the sentence. So just to make sure, your hypothesis generally is your P. Your Q, P and Q are flipped. The inverse is the not. The contrapositive is the not, but the converse of that. The converse of the inverse, yeah. Okay. Now, on your midterm, you are going to be required to know these translation rules. You actually need to memorize them. Very important right here. These ones, also important, but not as important as the rotations. And the reason is because line reflections, you can always like count over, like you can reflect over. So for example, if I had a line, and let's say I drew a line like this, and I'm looking at the point, let's say 3, or excuse me, that's a 2, 2, 3. So here's the point, let's call that A, 2, 3. And a line reflection, for example, if I want to flip this over the x-axis, this being my x-axis, right? So I can just count that. I went up 3, I'm going to go down 3, okay? So this right here would be my point, A prime, right? So A prime, and that would be 2, negative 3. So you can see that, see the x, negative y, all I'm doing is the negative y is changing. I can work that out. Like it's something that you can work out by just looking at it. Likewise, if I wanted to reflect this over the y-axis, so for this one, and I had this point A, 2, 3, and if I were reflecting it over the y-axis, which is this axis right here, if I went over 2 this way, this would be over 2 here. There's my A prime prime, and this would be negative 2, 3. And notice for this one, see the negative x, y, that's what would happen. You have got to remember these translation rules. You have to memorize them. These ones, very, very important. For this, for a translation, what you do need to remember for a translation is just that a translation is just adding or subtracting a value to your x and your y. A dilation is just multiplying a value to your x and your y. So if it's multiplying a number that's greater than 0, then you're actually expanding it. It's getting bigger. If you multiply by a number less than 0, like or actually even a half, less than 1, a half or something like that, that's like contracting. So that's smaller. So we're not going to say 0, we're going to say 1, greater than 1 or less than 1. So I would like you to really memorize these here. This is so important. Please memorize these. Just look at them, a rotation. And by the way, capital R is rotation. If you look at the little r, that's a reflection. Reflection is like symmetric. Rotation is turning. Now, you will be allowed patty paper on your final, so that's something that you can use. If you feel more comfortable, like taking your shape or point or whatever it is and rotating it, depending if it's a clockwise or counterclockwise. Remember, clockwise is your negative value, and counterclockwise is your positive. That's the one that's going to the left like that. From whatever value, it's going to the left. Okay, so given that information, reviewing that information, we're going to start with the point negative 2, 2. So if I were to take that point, and this is just on this one problem here, and make it a little bit bigger, A negative 2, so here's negative 2, here's 2. So here's A, and it's negative 2, 2. And I want to reflect, I want to reflect that across the line x equals 1. I'm not actually reflecting it across the x-axis or the y-axis. I'm reflecting it across a line. So you will need to know that that's x equals 1 right there, and it's a line that does this. Okay, that's x equals 1. That's that line. If it's x equals, it's going to cross the x-axis. If it's y equals, it's going to look like horizontal like that. It'll cross the y-axis, okay? So we want to reflect this across that axis. And so in doing that, okay, to get this over here across this line, if I went over 2 and this is 1, so I'm going to count over 3. So if this was 1 and I count over 1, 2, 3, now I'm actually at over 4, up 2. So 4, 2. And so this would be A prime. So that's over 4, up 2. Okay, so that's done. So this is the point. A prime would be 4, A prime would be parenthesis 4, 2. This one right here is a dilation. Now, I don't actually need to graph that. I mean, I could if I wanted to, but I don't want to. All I'm asking for is the image. And so that's going to be that image. After I dilate it, that means I'm expanding it by 3. That means I'm going to multiply it. So this one, A prime, is going to be negative 2 times 3, which is negative 6. And then 2 times 3, which is, 6 again. Now, this one is one of those ones that I told you have got to memorize. Okay, I don't really can't stress that enough. You have to memorize this. And so what's going to happen is, oops, for this problem here, let me get rid of that. I need to rotate that around the origin, negative 90 degrees. And so basically what that's saying is I'm going to go that way. So I'm going to take negative 90, and that's going to be that value, okay, that coin for that value is y, comma, negative x. So going back, if you look at this negative 90 right here, this is the one I'm looking at, y, comma, negative x. So that means that whatever my point is, if my point for A is negative 2, comma 2, the rotation around negative 90 degrees is going to go to A prime, and take your y, see it goes y, so that's y, which is 2, and then negative x, which is 2. So that's taking my negative 2, and rotating it around that way. So what do we have now? And then lastly, we have this right here. It's a vector. And what this is saying to me is this. It's telling me my translation is x plus 4, comma, y minus 6. Okay? So that means that I take my point A, negative 2, comma 2, and that point is going to change to A prime, which is now going to be add 4, so negative 2 plus 4, which is 2, and 2 minus 6, which is negative 4. So that's my vector translation. Basically is just moving it to another spot. A transformation is given by this rule that I'm going to subtract 2 and add 1. Another way of writing that is what we were just seeing, which was like this. Totally fine to write it like that. I want to know what the image is from 1, negative 3 after I do this. So after I translate my point to this, what's going to happen? So what's going to happen is this. I'm going to take 1, I'm going to subtract 2. So my new point, I don't have a value for this point. I didn't give it a value. So let's just call this B. So B prime would be 1, I'm going to subtract 2, so I get negative 1. And I started off with negative 3. I'm going to add 1, so now I have negative 2. So that's my new point. But this one is asking for the pre-image, okay? Now that's asking me for, they're saying this is the answer. What was the question? Okay, that's the answer. What was the question? So basically what that's telling me to do is that's saying to do the opposite of that, okay? So if I started off with 1, that means I'm going to add 2. So that means that the pre-image adding 2 would be 3. And the other one, instead of add 1, I would subtract 1, and that'd be minus 4. So just check, because if this is my pre-image, okay, then when I do my translation, what should I get, oh, sorry, this is my answer. So I want to know what is it, that's not my pre-image. I'm asking what the pre-image is. So basically, this is the final answer right here. This is the final answer. And this is what I started with, okay? So just check. If that's my pre-image, then I would go 3 minus 2, which is 1. Negative 4, add 1, which is negative 3. So you can go backwards by doing the opposite operation from whatever you had in the translation. The next question says, OB is the bisector of angle AOC. So I'm going to draw angle AOC. So here's A, here's O, and here's C. I highly recommend that you graph everything, because if you don't graph it, you're just leaving a lot to speculation. And okay, so OB is the bisector. So here's OB, there's B right here. All right, it bisects this angle, so that means that's congruent to that. OC, oh, here's OC. So now they're saying OC, which is this, okay, is the bisector of BOD. Now, I'm thinking to myself, I don't see D on here. I don't see D. See BOD? So that must mean that this angle here, BO here, is got to come out this way, all right? Because now, if that's a bisector, OC is a bisector, then whatever this is here, that's the same value here, okay? We know that AOC is 60 degrees. So from here to here, that's 60 degrees. That makes this 30, that makes this 30. And if this is congruent to this, that also makes that 30. So our job is to find the measure of angle COD. So the measure of angle COD, oh, that's just 30 degrees. Okay. The next question says S is the midpoint of RT. So here's RT, S is the midpoint. Here's S, that's congruent to that. W is the midpoint of ST. Okay, so let's call that W now. And that means that little segment is congruent to that segment. We know that RT is 32. So this whole thing is 32. Well, that made that 16 and this 16, which also made that 8 and that 8. Find ST. So we know that the measure of ST is 16. WT, well, that's just equal to 8. And now we need RW. Where's RW? RW is this. Oh, that's what? 16 plus 8. So 16 plus 8, what's that? 24. Next question says, suppose that angle 3, this angle, is 3x plus 5. So 3x plus 5. And angle 4, which is this angle, these are not congruent, by the way. Keep that in mind. 4 is 6x plus 13. All right, so what do we know? Find the value of x. That's my job. I know that these two angles make a line. That's all I know. So that means that I know that I can add them up to equal 180 degrees. That's what we know about a line. These are called a linear pair. So we know that 3x plus 5 plus 6x plus 13 is equal to 180 degrees. So we've got 9x plus 18 is equal to 180 degrees. Subtract 18, so you have 180 minus 18. Borrows, do that stuff. 2, 7, 6, 162. There you go. Divide by 9. You might ask yourself, how do I know that 9 divides into 162? If you just add these digits, 6 plus 2 is 8, plus 1 is 9. 9 divides into 9. It's going to divide into 162. Anyway, so if I divide by 9, 9 divides into 100 or 16 once. Subtract 9, I get 72. 9 divides into 72 8 times, so x is equal to 18. So that was the answer because it just asked me to find the value of x. However, just a note to self, I am going to ask you to find the angles as well. So this would be 3 times 18, add 5. So if you took 18 and you multiplied by 3, what's that? 24, 2, 3, 4, 54. And 54 plus 5 is 59. So this angle right here would be 55 degrees. Therefore, 180 minus 55, okay, would be the other angle. So you can always find out both of the angles by just, subtracting and knowing that that adds up, that they're supplementary because they are a linear pair. The next question says, if M lies between L and N. Okay, so we know that M could be here. Here's L, here's N. Well, here's L, here's N. I could have M over here. Or I could actually have M in the middle. Okay, so I'm asking you, which one is not possible? Well, we know that LM plus MN is equal to LN. True statement. So that's totally possible. LM is greater than MN. Well, if it looked like this, that's totally possible. LM is L. Okay, this is an L, by the way. LM is congruent to MN. Well, that's possible if M is in the middle. LM is less than MN, possible. LM, this length here, is less than LM is greater than LN. Well, that's not possible because you're not going to have a part of the whole bigger than the whole. Okay, so that's no. The next question says, in this figure, BD bisects angle EBC. So we have BD. So that means that this angle here is congruent to this angle here. If the measure of angle ABE, so ABE, this angle down here is x minus 2, okay? Then angle EBD is 2x minus 9. Find x and the angles. There we go. So I know that these are the same angle. So they're both 2x minus 9. So, and I also know that the sum of these angles, here plus here plus here, those all add up to be 180 degrees. So really, we could say x minus 2 plus 2x minus 9s is going to add up to be 180 degrees. So we have x minus 2 plus, we have 4x minus 18. Remember, you have to distribute, okay, equals 180. We have 5x minus 20 is equal to 180. Add 20. 5x equals 200. X is equal to 40. Okay, so we found x. X is equal to 40. Now I have to find the angles. Well, I know that that's 2 times 40 minus 9. So 2 times 40 is 80, and 80 minus 9 is 71. So that's 71. So that means that's 71. And if x is 40, that means that's 38. Okay, so x minus 2. So you always can check too. So you would just say like the measure of angle ABE is equal to 38 degrees. You can say the measure of angle EBD is equal to 71 degrees. The measure of angle DBC is equal to 71 degrees. And if you wanted to check to see if you had the right answer, you're going to add up these three angles. Don't add up 40. That's not an angle. That's x. In this case, sometimes x can be an angle, but for these values here, this is not. 71 and 71, so that's 142. 142 plus 38, 0, 1, 4, 5, 6, 7, 8, 180. So we want it to be 180 degrees. If it wasn't 180 degrees, then the angles didn't add up to be aligned and we did something wrong. We would go back and check it. The next question says, the measure of the complement of an angle is 2 times the measure of the supplement. This is where this is an angle. So for example, if I have a right angle, okay, there's a right angle, and I know that this angle right here, I'm going to say is x, not x, but x degrees. This part of the angle right here, if this is all adds up to be 90, right? Both of the angles, because they're complementary, then this would be 90 minus x. So we call that the complement. So this right here is a complement. This is the angle, that's the complement. Now, likewise, if I have a linear pair like this, something like this, and I said, hey, this is angle x degrees, not x, x degrees, then we know that this is a sum is equal to 180 degrees. So therefore, this is 180 minus whatever x degrees it was. For example, this could be 50. 180 minus 50 is 130. Now, what's going to happen is you're going to get some information, and for this problem, all I want to do is find x. Most of the problems, I'm going to find the complement, the supplement, and everything else. But this one, we're just looking for x. So when it says the measure of a complement of an angle, what they're saying for that is that's 90 minus x, okay? And this is a degree here. Is means equals 2 times the measure of the supplement. Now the supplement, if somebody says supplement, you need to write 180 minus x. If somebody says complement, you write 90 minus x. If somebody says supplement, you write 180 minus x every time. So now I'm going to distribute, I've got 90 minus x is equal to 360 minus 2x. I'm going to get everything on the same side. So we got negative 2x. I'm going to add 2x to both sides. So that's going to give me x. I'm going to subtract 90 from both sides. I'm going to get 270 degrees. So x is equal to 270 degrees. All automatically, you note there's no supplement, and because supplements only add up to be 180, there's no complement, and that's only going to add up to be 90. So not the best example. Find A and the measure of the angle. Well, we know that these two angles are vertical angles, so vertical angles are congruent. So we have x plus 16 is equal to 4x minus 5. Subtract x, I get 3x, add 5. So if I were to add 5 here, I get 21. So I get x equals 7. So I found x. There it is. Now, or A. Sorry, I used A. I guess this should say find x. Now I need to find the measure of the angle, or angles, okay? And you know that because vertical angles are congruent, those angles are the same angle. So finding the same, so what do I have to do? Plug in 7. So we're going to go 7 plus 16, right? Is 23 degrees. I also could go 4 times 7, which is 28, minus 5. 28 subtract 5 is also 23 degrees. So these should be the same angle because they're vertical. They have to be the same angle. The next question is a proof. Now, proofs are fun. Proofs are a friend. Yeah. Okay. What we are given is this, that angle 3 is a supplement of angle 1. So there's that is equal to that. And 4 is a supplement of 2. That equals that. Now, I mean, you know, I know there's lots of different ways to do a proof, to complete a proof. The way that I'm going to do this proof is I'm going to first write given. So the given statement says angle 3, and you just write it out, is a supplement of angle 1, and you would say angle 4 is a supplement of angle 2, and this is given, okay? 2 and 2. Second step. Now, if somebody says that something is a supplement of something else, that means that they add up to be 180 degrees. So technically, I can say the measure of angle 3 plus the measure of angle 1 is equal to 180 degrees, and that's the definition of supplementary angles. I also can say the measure of angle 4 plus the measure of angle 2 is equal to 180 degrees. So I could say that to both. Number 3, I know that 180 degrees is equal to itself. So I'm going to substitute this statement right here in here because I know they're both equal to each other, so that's substitution. So it's going to be the measure of angle 3 plus the measure of angle 1 is equal to the measure of angle 4 plus the measure of angle 2. And this is substitution, property of equality. Okay. Now, I'm stuck unless I have some more information, and I do have some more information in that, see angle 1 and angle 2. Some of you might have already picked up on that. Those angles are vertical angles. Okay, while we are trying to prove that angle 3 and angle 4 are congruent, and angles that are supplementary to each other are congruent. So there is a theorem for that, but this is just another way to do that, and that's actually proving that supplementary angle theorem. We do need to say that angle 1 is congruent to angle 2, and that's the vertical angle theorem. Vertical angles are congruent. Some people just write VAT. I like to write vertical angles are congruent. I mean, like I like to write it like that. Whatever. Angle 1 and angle 2 are the same angle, which means this. It means that if I were to subtract the same angle from both sides, I'm going to be left with angle 3 congruent to angle 4, and that is because I subtracted. So that's the subtraction property of equality. And oh, by the way, because these are, I went from measurement to equality, this actually wouldn't be the property of equality, it'd be more property of congruence. I could have said the measure of angle 3 is equal to the measure of angle 4. That would be the subtraction property of equality, because one's using a congruent sign and one is just using the equal sign. The next question says, supply in the reasons to justify these steps. Looks like these are both given. So this is given, 1. I'm going to make a little line here. Let's see here. Just make a line, 1, given. Okay. These are both given. So this would be my second step, third step, fourth step. So second step, third step, fourth step. So these are both my givens here. And it looks like y equals 12. Okay. 5x equals 2x plus y. There's my equation. So 5x equals 2x plus 12. What they did was they replaced y with 12. And so that's the substitution property of equality. This looks like I subtracted 2x from both sides, so that's the subtraction property of equality. Now, if you can't tell the difference between these two, and I know it's a little bit hard, but this was substitution, okay? You're not going to get credit for either, so make sure that you write really nice. Try to write better than me. Write nicer so that we can distinguish between substitution and subtraction, because if we can't distinguish between the two, it's going to be wrong. And then you have divide by 3, so this is the division property of equality. Okay, cool. Next question. So the next thing that we're going to talk about is we're going to review logic just a little bit, and we're going to do a couple of problems in logic. Rule number one, do you remember the rule that conditional statements are the strongest? They're stronger than all three of the other connectives, which is adjunction, conjunctions, negations, and, not biconditionals. Biconditionals are stronger than the conditionals, but conditionals are stronger than everything else. The weakest link is the negation, okay? That's always the weakest. Conjunctions, that should say conjunctions and disjunctions, they are equal. They have equal strength. So if you have a sentence that has both of them in there, like let's say this is your or and here's your and, right? There's no parenthesis there. So there would be no conclusion for this one because none. You write none or no conclusion because they both have equal strength. So you don't really know what has the strongest connective. But this one right here, because this is outside of the parentheses, that's strong. That has the strongest. So whatever's outside of the parentheses has the strongest connective. So here's some problems right here that are asking what the major connectives are. So don't include the parentheses. They don't count. So you're looking at this right here because that right there, conditionals always have the stronger connective unless they're in a parenthesis like this one right here, okay? We have not A or B, and if not A or B, then C happens. Conditionals don't need a parenthesis, okay, to be the strongest. But in this case, see, here's my conditional here, but outside of my parentheses is this, disjunction. So that's the best. So that's the strongest connective. This one is another conditional because it's out. You don't need a parenthesis for that. So that's another conditional. And lastly, this looks like this. And look, I have no parentheses, people. So that's just none. If you don't have parentheses and you have a conjunction and a disjunction, same strength. State the justification for each. So we know if AB is equal to CD, and we know CD equals EF. This is just written a little bit weird. Then AB, this one, is equal to EF. This one, well, that's the transitive property of equality. So transitive property of equality. AB plus BC, those are little segments, right? Is equal to the big segment. That's the segment addition postulate. Now this one says if AB is equal to CD, also EF is equal to GH. I can take my AB and my CD and I can add the same value. See how these are the same value? See how I'm adding the same value to both of my terms, AB and CD? That's called the addition property of equality, okay? So I could write that out or I could use abbreviations. Either one is fine. The next question says the supplement of an angle is 4 times the angle. Okay. Find the measure of the angle, find the complement, find the supplement. Okay, so let's figure this out. Supplement, that's the word. Supplement, you're looking at this word 180 minus x. A given angle, that's your x. Is 4 times the angle. All right, that's it. Add x, I get 5x is equal to 180 degrees. I'm going to divide both sides by 5. 4 into 180 is what, 45? So 5 is going to be about 36. X is 36. So what that means is x here, that's my angle, 36 degrees, okay? So if my angle is 36 and I had a right angle, right, and that was down here, 36 degrees, what is the complement? Okay, so the complement would be 90 minus 36 degrees, okay? So that's going to be what, 54 degrees, okay? Now, to find my supplement, that looks like this. And so if I have a supplement and one of my angles is 36, this is going to be 180 minus 36. So take 180, subtract 36 degrees. So that's what, 4, 8, 7, 44, 144. So that, okay, so when you're taking a test, you're going to write this. You're going to say my angle is equal to 36 degrees. My complement is equal to 54 degrees. And my supplement is equal to 144 degrees. Okay. Okay, so this one says so I would graph this. You need to graph these. It says point A is 6, 4. So let's see here. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So here's A, all right, 6, 4. And B is -2, 1. So there's B, which is -2, 1. And C is, that's 6, so 5, 0. So there's C, which is 5, 0. Okay? So connecting these points, I got a triangle. And, okay, that didn't work. Let me fix that. So connecting these points, I have a triangle. Okay. Still having a little trouble, but there we go. See if that could work. Okay. So your job is to do this translation. So what that says is take R, little r is a reflection about the x-axis. So this is my x-axis. It wants to reflect it over the x-axis, okay? So reflecting that over this axis, right? So think about it. If I went over 6 and up 4, to reflect it over my x-axis, I'm going to go over 6 and down 4. So there's A prime, 6, -4. So what that means is, and like I was telling you, everything else is pretty, I think it's easy to figure out. The rotations are the most difficult, but these ones you can figure out. See, these x's are the same. So this rule goes x, -y. It's the opposite of that y. So this one here should be the same, right? Because it's 5, opposite of 0 is still 0. So C is C prime. But this one here, B, I'm going to go x, which is -2, and then -y. So -2, -1. Hold on. If I went over 2, up, oh, that looks like I went up 1. But actually, that looks like I went up 2, but I actually only went up 1. So over 2, down 1. So this point, this new point, B prime, is going to be -2, and see the -y? So the opposite of that, so -1. So adding or connecting your points here, that's what that looks like, okay? So that's what I'm going to ask you on the test. So you're going to need to know how to find, a reflection across the x-axis. Oops. Okay, there we are. Okay, so now this one is saying, given these points, again, these are the same points. So 6, 4, so there's my A, and that's 6, 4. B is -2, 1, so B is -2, 1. And C is 5, 0. So there's C, which is 5, 0. And we've got our connect the points like that. What are they asking? Rotate it 90 degrees negative. So what that is telling you is that you need to rotate it around the origin -90 degrees. So remember that rule for rotating -90 degrees. If you remember, it was y, -x. You need to memorize these values. Now, I will say that you do have patty paper, and so you can use the patty paper to do your rotations, and that's completely fine. But what you would be doing is taking each one of these and using this formula to find them. And so you're going to go 6, 4 is now going to become A prime, which is going to be y -x. So it'll be 4, -6. B prime will be y -x. So it'll be 1 and the opposite of x, which is going to be 2. And C prime is going to be y -x. So that's going to be y, which is 0, and then -5. So that's going to give me my rotation, -90 degrees, about the origin. So here we go. Let's see here. 4, -6. So here's A prime. 1, 2. Here's B prime. And C is 0, -5. And so that's 0, -5, and that's C prime. So this is my new picture, and that's my triangle that's been rotated -90 degrees. You need to make sure that you understand that when you do a rotation, all those points, if it's about the origin, see there, see the 0 right here? That means it's about the origin, okay? So, okay, let's move on. Next question says, given the composite transformation, which transformation is performed second? You always do the inside value or this first value first. So the second one is going to be this. So my first transformation is going to be my dilation. And that, see how this negative 2, I'm going to multiply everything by negative 2. My second translation is going to be a reflection across the y-axis. Okay? So 29. Given this information, you have f of x is that, g of x is that. Your job is to solve for this. Now, you always do the inside first. Inside and then out. So first we need to do g of negative 2. And so that means that this value right here, this x, see negative 2, this is going to replace x. A negative 2 squared, which is negative 2 times negative 2, which is 4. So we know that g of negative 2 is equal to 4. That means this value in here is 4. Okay? So now what I'm looking for the second part of this is f of 4. So f of 4 means I need to plug 4 now into the f equation, whereas this negative 2 I plugged into the g equation, 4 I need to plug into the f equation. So that's going to be 4 minus 1 cubed. So 4 minus 1 is 3, 3 to the third power, 3 times 3 times 3 is 27. So therefore, these three dots mean therefore, f of g of negative 2 is equal to 27. So if r is the midpoint of tx, so I'm going to write there's x, there's t, and r is the midpoint. So here's r, and as soon as somebody tells me that something is the midpoint, I'm going to do that because that reminds me, hey, those are congruent. Midpoint, I could say this is the midpoint, so therefore by the definition of a midpoint, that left side is equal to the right side. Or I can say if r is the midpoint, then tr is half of the whole length. That's your midpoint theorem. This is telling me that tr is 14c plus 7, and it's telling me that our x is 2c plus 139. Your job is to find tx. So tx, oh, they want the whole length. Well, I know that equals that. So I can just say 14c plus 7 is equal to 2c plus 139. So I'm going to subtract 2c, and I'm going to get 12c. I'm going to subtract 7. If I subtract 7 from both sides, I get what? 132. And so 12c equals 132. If I divide by both sides, right, I'm going to go 132 divided by 12. And so you guys, most of you know how to do this. If you don't, you're not allowed a calculator. So you're just going to do this, and you're work it out if you don't know what it is. So that's just 11. Subtract 12, we get 0 remainder. So divide by 12, we get 11. So C is 11. Now, be careful because C will definitely be one of the choices. That might be like A. And then here's B, here's C, here's D. I might say B is equal to 132. Then I'll have 11 there. I might have 14 here. So I'm going to give you some tricky, some questions that aren't, the answer. Because I didn't ask for C. I didn't ask for what the answer was. I asked for TX. So this is TX. You see that? All right. So that means I need to plug in this. So if I had to plug in 11 to C, I'm going to go 2 times 11 plus 139. So that's 22 plus 139. So what is that? 22. So if I add 139, I get 1, 3, 4, 5, 6, right? 9, 10, 11, 1, 3, 4, 5, 6, 161. So there's 161. That's my answer because that is oh, no, hold on a second. What did I just find? Whoops. That's not the answer. Because what I just found, I believe, was this part right here. So that's 161. So keep in mind, once I have that, 161, this is 161. So they want TX, they want that whole length. So 161 times 2, right, is 2, 12, 1, 2 plus 1 is 3, 322, finally. So TX is equal to 322. So there we go. That concludes the first part 1 of the midterm 1 review. If you continue watching, or if you watch the second part 2, what I'm going to be going over is the midterm review packet. So I hope you have time to watch that before your midterm. And if not, good luck. Thanks for watching. I hope that helped you in some way. All right.